Stop spraying WD-40 on your locks. It's not lubricating them, it's destroying them slowly. There's a $3 powder that locksmiths actually use, and it lasts years, not days. Your front door key is harder to turn than it used to be. Your car door lock sticks in winter. That hinge on the back gate squeaks every time someone walks through. You grab the blue and yellow can. You spray it generously. For a day or two, everything moves smoothly. Then it's back to sticking. Sometimes worse than before you sprayed it. Here's what the can never tells you. WD-40 was never designed to be a long-term lubricant. The name itself, water displacement, 40th formula, tells you its original purpose. It was created to displace water and prevent corrosion on missile components, not to lubricate moving mechanical parts long-term. It's a solvent carrier with a light oil. The solvent evaporates within hours. What's left is a thin oil film that attracts dust, dirt, and grit. Inside a lock, that grit combines with the residual oil to form a gummy paste. That paste is often the actual cause of the stickiness you're trying to fix. Locksmiths have known about a specific powder for over a century that solves this completely differently. Graphite. A dry lubricant that doesn't evaporate, doesn't attract grit, and actually improves the longer it's used. They cost $3 to $5 for a bottle that lasts years. And most hardware stores stock it 3 aisles away from the WD-40 display, where almost nobody looks. Stay with me. Because what I'm about to show you is going to change every lock, hinge, and lubrication job you do in your house from now on. First, why WD-40 actually makes most lock and lubrication problems worse over time, not better. Second, the exact physical mechanism that makes graphite a permanent solution instead of a temporary fix. And third, the complete protocol for locks, hinges, sliding tracks, and the one surprising place graphite should never go. Don't go anywhere. Before the full explanation, here's exactly what you're going to do. Powdered graphite, sold in a small squeeze bottle with a narrow nozzle. For locks, insert the nozzle into the keyhole and give 2 or 3 light puffs. Insert your key and work it in and out several times to distribute the powder. For hinges, apply a small line of powder along the pin and work the hinge back and forth. That's it. No spraying, no wiping excess, no mess. One application lasts months to years, depending on use frequency. Now let me show you why this dry powder outperforms every spray lubricant on the shelf. Here's what's actually happening inside a lock or hinge that's been sprayed with WD-40 repeatedly over the years. WD-40 is roughly 50% solvent, usually a petroleum distillate, with the remainder being a light mineral oil and a small amount of other additives. When you spray it into a mechanism, the solvent does its job immediately. It displaces moisture and temporarily loosens whatever was sticking. That's the satisfying moment when your key suddenly turns smoothly again. But within a few hours, that solvent evaporates completely. What remains is a thin film of mineral oil. This oil film is sticky enough to attract airborne dust, dirt particles, and metal shavings from the lock's own internal wear. Over weeks, that combination of oil and grit thickens into a paste. The paste increases friction rather than reducing it. This is why a lock sprayed with WD-40 6 months ago often feels worse than a lock that was never sprayed at all. You haven't just failed to fix the problem. You've added a layer of gunk that makes the next repair harder. Locksmiths see this constantly. A homeowner calls about a stuck lock, and the locksmith's first job is often cleaning out hardened oil and grit residue from years of spray lubricant before they can even diagnose the actual mechanical issue. Graphite avoids this entire failure cycle because it never relies on an oil film that needs to stay wet to keep working. Here's the part that changes how you think about lubrication entirely. Graphite doesn't lubricate the way oil does. Oil works by creating a liquid film that keeps 2 surfaces from touching directly. Graphite works because of its molecular structure. Graphite is made of carbon atoms arranged in flat hexagonal sheets stacked on top of each other. The bonds within each sheet are extremely strong, but the bonds between the sheets are extremely weak. When graphite particles get caught between 2 moving metal surfaces, those weak interlayer bonds let the sheets slide past each other almost frictionlessly. It's not coating the metal, it's becoming microscopic ball bearings made of sliding carbon sheets. And because graphite is a solid, it never evaporates, never dries out, and never needs reapplication on the same schedule as oil. It also doesn't attract dust the way an oil film does because there's no sticky liquid surface for dust to bond to. The mechanism that makes pencil lead marked paper, graphite sheets sliding off each other onto the page, is the exact same mechanism that makes your lock turn smoothly for years. The household lubricant market in the United States generates over $800 million annually. WD-40 alone holds a significant majority share of that market, built almost entirely on consumer perception that it's a universal lubricant. Pull up the WD-40 multi-use product page right now and look at the recommended uses. You'll see rust prevention, loosening rusted bolts, displacing moisture, cleaning. You will rarely see long-term lock or precision mechanism lubrication listed as a primary recommended use, because even the manufacturer's own technical documentation acknowledges it's a short-term solution for those applications. The company makes a separate, less heavily marketed specialist lubricant line for exactly this reason. Most consumers never see it because the iconic blue and yellow can occupy the prominent shelf space and the brand recognition. Graphite, meanwhile, has been the locksmith industry's standard recommendation for lock lubrication for well over 100 years. It's in locksmith training manuals. It's what manufacturers of high-security locks recommend in their own maintenance documentation. Mool, T-Lock, Medeco, and Schlege's own technical service bulletins specifically recommend dry graphite lubricant, and specifically warn against petroleum-based spray lubricants for their cylinder mechanisms. That warning exists because the oil and grit paste problem is well documented enough that it shows up in warranty service calls. A $3 bottle of graphite that needs reapplication every year or two doesn't generate repeat purchases the way a spray can that needs reapplication every few weeks does. There's substantially less recurring revenue in a product that solves the problem permanently. Subscribe to Camping Prohibido and hit the notification bell. Graphite has been used as a dry lubricant since the early 1900s, when locksmiths and machinists first began documenting its advantages over the oils available at the time. Early 20th century industrial machinery, particularly in textile mills and printing presses, relied on graphite-impregnated bearings precisely because oil-based lubricants in dusty industrial environments suffered from the same grit accumulation problem you see in a sprayed lock today. Dust would settle on oiled bearing surfaces, mix with the oil, and create an abrasive paste that wore down the bearing faster than no lubrication at all. Engineers switched to graphite specifically to solve that problem in dusty factory environments. The locksmith trade adopted graphite around the same period for the same underlying reason. Lock mechanisms operating in dusty entryways and exposed exterior conditions had the identical failure mode. By the mid-20th century, graphite lock lubricant in small squeeze applicator bottles was a standard item in every locksmith's toolkit in most well-stocked hardware stores. Then, the post-war petroleum-based aerosol spray industry exploded. The WD-40 itself was developed in 1953 by the Rocket Chemical Company for the aerospace industry, specifically to prevent corrosion on the Atlas missile's outer skin. It worked so well for that narrow purpose that the company began marketing it to consumers as a general-purpose product in the early 1960s. The marketing was broad and aggressive. The actual chemistry remained narrow, designed for corrosion prevention and moisture displacement, not for long-term lubrication of precision mechanisms. But the can found its way into every household toolbox, and graphite quietly remained in the specialty hardware aisle, used mainly by people who already knew about it. What you just heard explains why the lock you sprayed with WD-40 last spring feels worse now than it did before you sprayed it. The solvent evaporated within hours. The oil residue collected dust and grit for months, and turned into the gummy paste that's making your key hard to turn right now. Graphite never creates that residue in the first place. What's coming next is the complete protocol. Locks, hinges, sliding tracks, and the one place you should never use graphite. Stay with me. Buy powdered graphite lock lubricant at any hardware store. It's usually in a small plastic squeeze bottle with a narrow application tip, often near the keys and locksmith section rather than the spray lubricant aisle. Price? $3 to $6 for a bottle that will last most households several years. Door and padlock locks. Insert the narrow nozzle of the bottle directly into the keyhole. Squeeze gently to release 2 or 3 small puffs of powder into the cylinder. Remove the nozzle and insert your key. Turn the key fully clockwise and counterclockwise 5 to 6 times. This action distributes the graphite powder throughout all the internal pins in the cylinder wall. Remove the key and reinsert it 2 or 3 more times to ensure even coverage. The lock should turn noticeably smoother immediately. If you have existing buildup from old WD-40 use, the lock may need a few cycles of turning to fully work the graphite past the old residue. For locks that are severely stuck from years of oil and grit buildup, a locksmith or hardware store can supply electrical contact cleaner, a solvent that fully evaporates without residue, to flush the cylinder first. Let it dry completely, then apply graphite as described. Door hinges. Open the door fully to expose the hinge pin. Apply a thin line of graphite powder along the top of the pin where it's visible between the hinge barrel sections. Work the door back and forth through its full range of motion 10 to 15 times. This works the powder down into the hinge barrel and around the pin. For severely squeaky hinges, you may need to lift the door slightly to relieve weight on the pin while working it back and forth for the powder to fully penetrate. Sliding door and window tracks. Clean the track first with a dry brush or vacuum to remove loose debris. Apply a thin, even line of graphite powder along the entire length of the track. Slide the door or window back and forth several times to work the powder into the rollers and track contact points. This is particularly effective on aluminum sliding door tracks, which tend to develop the same oil and grit gumming problem if ever treated with spray lubricants, drawer slides, and cabinet hardware. Apply a small amount directly to the metal slide rails before sliding the drawer in and out several times. Combination locks and padlocks. Apply directly into the shackle holes and around the dial mechanism for combination locks, working the dial through several full rotations afterward. The one place graphite should never go. Electronic or smart locks with circuit boards or sensors near the mechanism. Graphite is electrically conductive. If powder migrates onto exposed circuit contacts inside an electronic deadbolt or smart lock, it can cause a short circuit or interfere with the electronic components. For smart locks, use a lock-specific lubricant recommended by the manufacturer, which is typically a non-conductive synthetic dry lubricant rather than graphite. For all standard mechanical locks, hinges, and sliding mechanisms, graphite is safe and effective. A homeowner in Chicago had a front door lock that had been progressively sticking worse for 3 years, despite spraying WD-40 every few months. By the third winter, the key would barely turn in cold weather, and he was considering replacing the entire lock cylinder. A neighbor who works as a locksmith suggested cleaning out the old residue with electrical contact cleaner and switching to graphite.